Sheet 7.2, solving exponential equations and inequalities. So we're going to solve these exponential equations. The key thing for this whole lesson is knowing your powers. That's it. You know your powers. Because the first rule here, I'm actually going to start with this one, is you want to make the powers the same. You want to make the bases the same. So you have to rewrite this one as a power of 5. So 125, you have to know, is 5 to the third. This is 5 to the x minus 6. Once the bases match, you can just solve the exponents. X minus 6 equals 3. Add 3 over. X equals 9. That's all it is. In this case, you don't have to worry about the domain because the domain here is all real numbers or exponents. The domain is all real numbers always. So you're just done. And you can check your work, plug it in, make sure you did it right. But that's your answer. This was the first one, I'm going back to the first one, it's a little tougher because, no it's not actually. I was thinking something else. 64 is just, you can write that as 8 squared. So 8 to the 4x plus 2 equals 8 squared. Once the bases match, you just solve the numerator, the exponential powers. So you get this, subtract 2, 4x equals 0, don't be scared, divide by 4, x is equals 0, that's a totally fine answer. Again, plug it in, check your work, there it goes. Let's keep on doing these. The next one, I want these to match, so I can't do anything to 3, 3 is as low as it goes, but 81, you gotta know 3 double power is that. 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81. So 3, 4, then a plus 2 equals 3, 3a plus 1. Very important right here, if you notice, I put parentheses because it's 4 times both of these, not just the a. So the most common mistake is when people just multiply the 4 times the a, is by both of these. So now I just solve this. 4 times a plus 2 equals 3a plus 1. Distribute that 4 both, so 4a plus 8 equals 3a plus 1, minus 3a, minus 3a, minus 8, minus 8, I'm on different sides. A equals negative 7. Again, if you plug it back in, check work if you want. Next one, again, I want these two to match. So 7 is as low as it goes, but 49 I can work on. 49 is something as 7 squared, so it's going to be 7 squared x plus 5. Equals 7 to the 8x minus 6. All we want to do is solve these I can't say numerator, the powers. 2x plus 5 equals 8x minus 6. Distribute. 2x plus 10 equals 8x minus 6. Solve for x, so plus 6 minus 2x minus 2x. I get 16 equals 6x. Divide by 6. X equals 16 over 6, or 8/3. Next one is what I was thinking of earlier. Okay, finally. So look what's happening here. You have 8 and 16. Powers of 8. I can't just go 8 squared. 8 squared is 4, so it doesn't go to 16. I actually got to rewrite both of these in these cases. What's then they both go into? 16 is 4 squared, but I can't do that with 8. So it's 2 actually. 8 is 2 cubed. 2y plus 4. And 16 is 2 to the 4th. Y plus 1. So I had to work on both sides. I had to rewrite 8 as 2 cubed and write 16 as 2 to the 4th. And now the bases match, and I can just solve the powers. So 3 times 2y plus 4 equals 4 times y plus 1. Distribute 6y plus 12 equals 4y plus 4. Do some math. So 2y equals negative 8. And then y equals negative 4. So there you go. Next one, same idea. I can't write 9 squared is 81, so it's already dead. So you have to the same base. These guys both go into 3. Or you can rewrite them as the power of 3. So this is 3 squared, 3c plus 1. And this is 3 cubed, 3c minus 1. Solve the tops. I'm going to save a little space by distributing from the top. So 6c plus 2, let's mess that up, equals 9c minus 3. Solve it. Minus 6c plus 3 plus 3. 5 equals 3c. Divide by 3. C equals 5/3. There we go. Next one. This one I need my calculator on. Where a is the amount in the account for T years, P is the principal invested, R is the annual interest rate, and N is the number of pounds per year. Find the balance of an account after 7 years if $700 deposited into account paying 4.3% interest. Right, so it's all about knowing what each thing means. So A is the amount you have after so many years. It's like the total amount after so many years. P is the initial value, the principal, also known as the deposit, initial value, deposit, all that same. So right here, that's my P. R is annual rate, so right here, R. Now remember, it has to be in decimal form, not form. So move that decimal over 2 spots. And then 7 years is my T, my years. And compounded, how many times you compound it? Now monthly, means you're compounding it once a month, so that's 12 times in a year. So that's probably the toughest one. Compounded means how many times you compound it in that year. So monthly is 12 times. So we have all that, plug it into the equation. So A, I don't know. P is 700. 1 plus my 0.043 over 12, and then 12 times 7. So like that. If you don't have a calculator, that's fine. Just leave it like that, and you are done. If you do have a calculator, we'll take care of it. Like now. So got it out. 700 times 1 plus 0.043 divided by 12. Close, caret, then 12 times 7. Now I can just put 12 times 7 because they're both as an exponent, so that works. And we get $945.34. Boom. So there we go. So remember how much is in the retirement account after 20 years if 5,000 was invested at 6.05% interest compounded weekly. So I try to skip through that. So after 20 years, that's my T. We deposit this much, so that's my P. My R is 0.0605. Compounded weekly, number of weeks in a year is 52. So same idea, but new numbers. 0.0605 over 52 times 52 times 20. So we'll hold it in there for 20 years. So let's bring up the calculator again. So this time it's, move it over here so you can see it better. There we go. 5,000. 1 plus 0.0605 divided by 52. So the 52 times 20. Multiplication in there somewhere I need. There we go. And I get 16,000. It's almost triple the money. You gotta wait like 20 years for it though. 755.63. There we go. So that's how you use interest. Next problem. Write an exponential function for the graph that passes through the given points 0.64 and 3 and 100. So we have this equation. So the key thing here is, keep in mind these are x and y's. So we want to write an equation for each one. So we're going to use this equation for each one. So let's do it here first. So y, 6.4, equals ab to the x, which is 0. And over here, right, I'm plugging from my y and my x. Y is 100, and ab to the third. So now we have two equations. Just using this equation here and plugging both of these in for x and y, I'm trying to find a and b. Then I can rewrite it. So what we do next is this one. We have a b to the 0. We know a to the 0 power is 1, so that's 1. So I'm left with just a equals 6.4. How nice. Only if there's a different equation I can plug it into. Hey, right here. Now you know a is 6.4. Sub it in, and then solve. Right, now I can solve for b. Let's divide by 6.4. Oops, 6.4. And 100 divided by 6.4, I'm not totally sure. So let's do it on here. And we get 15.625. So b cubed goes 15.625. Now I got to cube root both sides. Just to get rid of the cubed. So now I'll go math, cube root. So now I want my answer from before, so I'm just going to go up and select it. You can also press answer down here. We have to do second though. Hit enter and get 2.5. Now keep in mind, I'm not done. The question wasn't find A and B. It was like find an equation. So I gotta rewrite this as an equation now. So I just gotta plug back into here. So y, you always want to leave y and x alone when you rewrite the equation. 6.4 times 2.5 to the x. There you go. That's my equation. Right? So you use the points to plug into the equation, solve for one of them, plug it into the other one. Once you get your 2 points, rewrite it. So let's do it again. Here's the x and y, exact same question. So over here it's going to be 256, just using this equation, equals ab to the x, which is 0. And over here it's going to be 81, equals ab to the x, which is 4. Just like before, and it's like in most algebra 2s, hey, this cancels out and you just get a 1, so it's a equals 256. It's not that much harder when there's a number there, but you won't do this here. Anyway, now I can plug this into here. 81 equals 256. B to the 4th, divided by 256. So I get 81 over 256 equals B to the 4th, and then we'll take the 4th root of both sides. And then the 4th root, 81 is 3. The 4th root of 256 is 4, so that's my B. Rewrite it. A equals 256, 3/4 to the x. And there we go. Next one. 2009, Mai Lin received $10,000 from her grandmother. That's a nice grandmother. Her parents invested all the money, and by 2021, the amount will have grown to $16,960. For an exponential function that could be used for the model and write the function in terms of x. So initially I thought it was going to be this form, but it actually isn't. This one's an exponential function. So it's actually kind of like the one we just did. In 2009, let's call that year 0, we got $10,000. And in 2021, that's what, 12 years later, we now have $16,960. So we got to make an equation just like we did before. So the last couple problems. So in this case, here's my a, here's my x and my y. So if $10,000 equals ab to the x, and over here 16,960 equals ab to the 12. I guess my x over here should be 0. This reduces, right, to b to the 0 power is 1, so you have a equals $10,000. That's my initial amount. Plug it into here. So I get 16,960 equals $10,000. B to the 12th. Well, divide by $10,000. And I'm going to get b to the 12th equals, I'm going to put that in my calculator, I don't know what that is. 16960 divided by 10,000. That's the right number of zeros. 6.61? Yeah. 1.696. And then I gotta take the 12th root of both sides. So, right, 1/12th root both sides. So how do you do that on your calculator? Well, if you go to math, right, there's a button right here that has an X in it. That lets you put any power you want. So I press that. I just gotta change that to 12. And then put them out here. So I'm gonna press answer. Second answer. That's unplug that number in. And I get 1.045. Let's equal to B. So there's my equation. Y equals $10,000, 1.045 to the x. And then the question is, for the next one, assuming the amount of money continues to grow at the same rate, what would be the balance in 2031? So that's another 10 years. So it was already 12 years. So that's another 10. So it's 22 years. So I have to plug 22. X equals 22 in for that. I was doing the calculator. So if we do this in the calculator, it's going to be 10,000. Then I have my answer here. I'm plugging it for 22 years. I get $26,339. So there we go. That's the answer. That's a little weird, but that's the answer. Okay, last one, inequalities. So the good news here, they're exactly like the other problems. The domains are numbered, so actually inequalities here have they don't change it besides the fact that it's an inequality. We're going to solve them just like we did before. So if I want these to, I want to solve this. I gotta get the bases to match. 5 as far as as low as it goes. How about 625? What is that? That's 5 squared is 25. 5 third is 125. 5 to the 4th is 625. So 5 to the 4th is greater than equal to 5 to the 8 plus 4 8. Once the base is matched, solve the powers. 4 equals an 8. 4 is greater than equal to 2. 8 plus 8. Then we just gotta solve. Minus 8 minus 8. 4 is negative 4 is greater than equal to a. Or if I'm going to rewrite it, a is less than equal to negative 4. The next one, same idea. I got to get them to the same base. Now, 64 and 32 don't go together, so either write them, both of them, break them down. 64 can be broken down as an 8 squared or 4 cubed, or 2 to the 5th. 32 is only 2, actually 2 to the 6th. 2, 30, 18, 16, 5, 6, okay. 2 to the 6th is 64. And 2 to the 5th would be 32, so the only thing it breaks down to, so we have to use 2's. So this is going to be 2 to the 5th, 2c. Over here, this is going to be 1 over 2 to the 6th, c minus 2. We still have a problem. This is a 2, this is a 1 over 2, those are not the same. You got to flip one of them. Let's flip this one. How do you flip it? You make it a negative power. That's how you flip it. So it's 2 to the negative 6, c minus 2 is less than 2 to the 10c. Forget power to a power, you multiply. So we have this. Now you just solve the numerator. Always the numerators, the exponents. So I get negative 6 c minus 2 is less than 10c. Distribute. Negative 6c plus 12 is less than 10c. Add the 6 over. 12 is less than 16c. Divide by 16. 12 over 16 is less than c. Or if you prefer the c on the left hand side, 12 is greater than 12 over 16. Right? If you switch it, you got to flip the sign also. So you get that one. Down here, same idea. So let's rewrite these. How can we write 9 and 243 as the same thing? 9 is 3 squared, and 243 is 3 to the 5th. So yeah, let's do it like that. So this is 1 over 3 squared. 3t plus 5. And this is 1 over 3 to the 5th. T minus 6. Now the bases actually match here, so I could cancel them out, but don't forget the 2 and 3 are still there. So the power 2 times 3t plus 5 is greater than 5 times t minus 6. Unless you just solve it. 6t plus 10 is greater than 5t minus 30. Well, the t is in the same spot. I get t is greater than negative 40. There. And the last one, similar idea. When I get the same base. Now in this case I should go a little bit, no I can't. 27 only breaks down to a 3 cubed, doesn't break down anything else. That was my mistake, I was thinking it's a 9 or something. So this is 3 cubed, 2d minus 2. Over here, since I broke this down to 3, you gotta do the same thing here. So that's 3 to the 4th. D plus 4. Okay, so again, they don't match actually. This is a 1/3, that's a 3, it's not the same. You have to flip one of them. I like to flip the flip one. I already flipped one. So let's flip that up and I'll make it a negative 3. So it looks like this. And over here, let's just simplify a little bit. So it'll be 3 to the 4d plus 16. So now the bases match. I can just solve the powers and I get 3 times negative 3. 2d minus 2 is less than 4d plus 16. Then we distribute. Negative 6d plus 6 is less than equal to 4d plus 16. Then we just solve. Minus 4d minus 4d minus 6 minus 6. Negative 10d is less than 10 divided by negative 10. Whenever you divide by negative, you got to flip the inequality. So d is greater than equal to negative 1. Anyway, that's it. And that's the worksheet.